Okay, welcome everyone to the CS Talk session 16 of the 7th Polygon Symposium of Writing Scholars. My name is Claire. I'm a product UX UI designer at Polygons, and I will be moderating this session today. The goal of the symposium is to really celebrate and showcase the hard work of our proud Polygon scholars, all whom have tirelessly worked on their projects over the past couple of months. We should be having 4 student presenters today on a variety of topics. A fellow member of the Polygons team will be scoring each student's presentation, which will help us determine prize winners after this event. So a note to all audience, please type your questions in the chat if you have any for each speaker. We'll have time dedicated at the end of the session for speakers to answer your questions. Let's wait a couple more seconds so our judges and our audience can come in. Okay, awesome. So let me start by introducing today's presenters here. So we'll start with Tony Wu, and then we'll go to Pavithra, Kamatchi, Soundaram, and we'll end with Shuhul, Mujoo. So we'll begin with Tony. I ask all the other presenters to turn off your microphone and camera off. And Tony, I will pin you so everyone can see your screen. And take it away. And Tony, I think you're on mute.
Yeah, I think it's better. Okay.
Awesome.
Hey everyone, my name is Tony Wu, and my research project is the analysis of text prediction for different natural language processing models. And again, my name is Tony Wu, and my mentor is Sarah Y. So, a brief introduction to natural language processing. So what exactly is natural language processing? Natural language processing, or NLP, is a field in machine learning where artificial intelligence, or AI, works with human language. Basically, we want a machine, such as a computer, to be able to understand and interpret different languages. There are many subfields of natural language processing, such as text prediction and text generation, which our presentation will focus on. Text prediction or text generation is when a machine is given a certain string of words as an input and tries to predict or generate what words go between or after our input. This is useful and has been implemented in a lot of real-world programs, including Google search recommendations, as shown on the slide, autofill in Microsoft Word, and even in Visual Studio Code. Okay. Over the past 10 years, there's been a significant amount of research that has gone into text generation. There are many different approaches and models, but most, if not all, use neural networks. One model, as shown below, separates each sentence by word and labels the sentence by the frequency of each word. So for example, the first sentence, the cat sat, is 1, 1, 1, and the words the cat sat, but all zeros and the rest of the words that don't appear in the sentence. So based on previous frequencies, Bag of Words is able to generate similar sentences, although it disregards word order and grammar. Similar to Bag of Words is Word2Vec. Word2Vec is a technique that represents each word with a specific list of numbers or a vector. So basically maps the words as a vector. So it uses a 2-layer neural network to produce a vector space, and often with over 100 dimensions, given a large corpus of words with each vector representing one word. Using the vectors of context words, Word2Vec can predict a word with some accuracy. The attention mechanism highlights relevant features in input data, while while ignoring irrelevant features. This means that it focuses more on relevant words than irrelevant words in a sentence for natural language processing. Similarly, the self-attention mechanism, as used in many models such as the transformer, looks at other words in the sentence to encode or decode a sentence. So some of the state-of-the-art models of natural language processing are GPT-2 and GPT-3, which stand for Generated Pre-trained Transformer 2 and 3. The models are similar to the transformer, except they are incredibly large and trained on massive data sets, which is the reason why they're better than most, if not all, the models that are available today. They're able to perform very well, having some of the best BLEU scores, which are scores for machine translation in the world. So, method. So our research method involved looking at the various text generation methods and implementing them in our own model. With the goal of creating the best text generation model possible, I chose to implement the word-to-vec and the transformer. The reason why we did this was for word-to-vec, it had superiority over other vectorization methods. For example, bag of words, it only labels the frequencies, whereas word-to-vec can retain the semantic meaning in words. The transformer, due to its high effectiveness and use in other state-of-the-art models like GPT-2 and GPT-3, was also chosen. To gauge its relative accuracy and effectiveness, I chose to compare my model with GPT-2. GPT-2 was the best open source model available to use, which is why it was chosen as a benchmark. Due to constraints such as time and processing power, I resorted to using the small version and would train both my model and GPT-2 using the same dataset, which I'll talk about later, along with similar time and processing constraints to get the fairest comparison possible. So on the right side here is the model architecture of the transformer that I tried to emulate. So the left side of the model is the encoder layer, which maps the input into a sequence of continuous representations. As you can see, there's multi-head attention and normative layers and feed-forward layers as well. On the right side of the model is a decoder, which is noticeably more complex than the encoder layer, which takes the output of the previous encoder layer to generate the output sequence. And as you can see, it has attention layers and softmax layers to get the output probability. Okay, experiments. For our comparison between models, we chose to use the New York Times comments dataset, which we found on Kaggle. Below is an example of a comment which says, "Hope your knee is better soon, Christine. Thanks for the chuckles this morning. It's a great way to start any day." So the datasets consisted of similar comments to these, which were found below New York Times articles during the mid to late 2010s. It was chosen because of the relatively few grammar mistakes in the dataset and of the many diverse viewpoints and backgrounds of the commenters. The dataset was contained a little over 2 million comments. So for data set processing, we split up the sentences into individual words and punctuation, and then all stop words like and or it, which don't add much meaning to the sentence, would be removed. Lastly, all symbols that aren't words like numbers and commas were removed, and all letters were changed to lowercase. For our experiments, we planned, but we haven't got this far yet, we plan to change the hyperparameters like weights and biases in our code and see which ones work the best. Results. Although we are not entirely done with our research, what we have found through the tests we have run is that our accuracy is slightly lower than the accuracy of GPT-2, which is around 5 to 10% lower. Because we aren't done with our testing, we've only gotten started, we do not know which model is more useful, although from our current results, it seems as though GPT-2 is better. So extrapolating a bit, this means that in the real world, it is unlikely for our current model to succeed. It is important to note, however, that it is still possible to have a higher accuracy than GPT-2 with our model, although it will require changes to the model architecture or hyperparameters, which we plan to do in the future to get better results. Limitations. That being said, our results do have some limitations. First, due to a significant lack of processing power, our model and GPT-2 had to be scaled down by a significant amount. So the word vectors, which commonly have over 100 dimensions, had to scale down to be less than that. And many changes to neural networks were also made. So, and second, another limitation is a lack of time. So this caused our model and GPT-2 to not be able to be trained on the same amount of time, which was common for bigger data sets. Our third limitation was that the data set we chose is significantly smaller than the training data used by state-of-the-art models. What this means is that our results can't necessarily be extrapolated on the large scale, although we do believe that our results are pretty accurate for evaluation on a small scale. This is a serious limitation as most of the state-of-the-art models are run on a much larger scale, so it would be hard to apply our findings to that. And thank you for listening, and I guess we will have time for some questions.
Awesome. Thank you so much, Tony, for the fascinating presentation on natural language processing. We do have a little bit of time left before we move to the next presenter. So I'm just going to ask you a question that was sent my way. What next question would you pose to the field of natural language that you've completed this project to continue your investigation in the field?
Well, currently, we're not entirely done. We do have to do a bit more testing, but I guess something I would like try to improve in natural language processing is to see algorithms and like different neural networks and how we can better them. Because over the past few years, natural language processing has grown as a field, and there have been a lot of different techniques that have come about. Like, I believe the attention mechanism was only proposed in the mid-2010s. So I'll try and look for different techniques that could make it more efficient or better. So yeah.
Sounds awesome. So I am now going to welcome our next presenter, Pavithra Kamatchi, Soundaram. Pavithra, when you're ready, I will pin your video, and when you're ready, start sharing your screen and take it away.
Hi everyone, I'm Pavithra Kamatchi Soundaram, and I work with my mentor Sejal Dua to detect Parkinson's disease at early stages using speech recordings through audio signal processing and machine learning. So, what is Parkinson's disease? Parkinson's disease is a highly prevalent neurodegenerative disorder in which neurons in the basal ganglia and substantia nigra die. The complications of Parkinson's disease are rated as the 14th cause of death in the US, in which speech deterioration and impaired movement are one of the first symptoms. The problem. So currently there's no single test to definitively diagnose Parkinson's disease, and therefore it's a very difficult disorder to identify. Many times, Parkinson's disease patients have only been diagnosed after 2 years of having symptoms, and 30% of the time, Parkinson's disease has been misdiagnosed. Since the disease worsens as you age and there is no cure, it's imperative that we identify the disease at a very early stage. In addition to that, current imaging tests such as the SPECT and DAT scans that doctors use are expensive and cost around $2,500 to $5,000. Due to this, I decided to create a free, easy-to-use audio signal processing tool to detect Parkinson's disease using speech recordings. For this project, I used an open access dataset called the MDVR KCL dataset from the King's College Hospital in London, which consisted of speech recordings of 16 Parkinson's disease patients and 21 healthy controls. Each speech recording is a phone call between the test executor and the subject. After some preliminary conversation, the subject is asked to read an excerpt from The North Wind and the Sun and a geography textbook. For pre-processing, due to the small sample size of my dataset, I decided to split each recording into 20-second sections so that I could get more samples for my machine learning model to train on. In order to split the audio files, I first used Python's VOSC library to transcribe the speech recordings. Transcription of the files was necessary in this case because the preliminary conversation between the test executor and the subject ended at different timestamps for each recording. If the test executor's voice was not taken out of the recordings, the detection accuracy of the disease would be very low since it would have trouble picking up on the speech deterioration. Using the transcription, whenever the phrase "the north wind and the sun" or the phrase "this is because there's less scattering" was recognized, the timestamp of that phrase was stored and the PyDub library was used to split the audio file at the specific location. After removing all of the preliminary conversation in each speech recording, the PyDub library was used to split the audio files into 20-second sections since it allowed for enough time for the voice abnormality to be displayed and detected. In the end, I obtained 145 audio samples from the 37 speech recordings in the original dataset. Now with 145 audio samples, I pre-emphasized each audio file to reduce the signal-to-noise ratio and use the Parcel Mouth library to extract acoustic features to train my machine learning model with. Some of the features I extracted included the jitter, shimmer, pitch, and harmonics-to-noise ratio values. Parkinson's disease patients are characterized with vocal features that fall under specific range of values. For example, a Parkinson's disease patient tends to have a higher value of jitter, which is the measure of short-term frequency instability and of involuntary changes in frequency compared to control subjects. The mean jitter value for a Parkinson's disease patient is 20, while for a control subject is 16. Similarly, Parkinson's disease patients tend to have higher shimmer values with a mean of 1, while control subjects have a mean of 0.05. By extracting these features, I generated a dataset of values to train my machine learning model. So in order to perform classification analysis, I created 4 supervised machine learning models: the logistic regression model, the support vector machine model, the XGBoost model, and the random forest model. After training the models on the extracted acoustic features from the pre-processed audio files, it was found that the XGBoost and random forest models both achieved the highest classification accuracy of 93.1%. On the other hand, the logistic regression model achieved a 91.38%, while the support vector machines achieved an 84.48%. This is very different from the model's accuracy when trained with acoustic features from the original 37 audio files, because as you can see, without pre-processing the audio files, the XGBoost model achieved a 60% accuracy, the random forest model achieved a 66.67% accuracy, the logistic regression model achieved a 33.33% accuracy, and the support vector machine achieved only a 53% accuracy. Due to the high accuracy of the XGBoost model, I decided to use the XGBoost model for my audio signal processing tool, which is currently underway. Even though both the XGBoost model and the random forest models have the same accuracy after increasing the sample size of the dataset, I chose to use the XGBoost model since in this model, each decision tree is built sequentially, and as each tree makes a prediction on whether the subject has Parkinson's disease or not, the gradient descent function is used to minimize the loss and calculate the weights given for the prediction for the next decision tree to learn from. By doing this, the model is able to identify the weak and strong acoustic features in the dataset and are given feature importances for the model to learn from. This is unlike the random forest model, which builds many decision trees, each which come up with a prediction for Parkinson's disease classification, and finally, based on majority voting, the final prediction is determined. So in this way, I determined that the XGBoost model would be more helpful for the audio signal processing tool that I'm currently making. Thank you.
Awesome. Thank you, Pavithra. I think we're doing great on time. That was a fascinating presentation on audio signal processing tool and Parkinson's disease. So before we move on to our next presenter, Shuhul, I'm just gonna ask you one question that was sent my way. One of the questions from the audience is, what initially drew you to research on this topic?
Can you repeat that question?
What drew you to research this topic?
So my grandpa, he actually had Parkinson's disease, and it was diagnosed at a very early stage, very late stage. So it was hard for any treatment to actually help him. And so I decided to do this project so that other people can benefit from early diagnosis.
Got it. I have one more quick question that was just sent to me. What are the next steps for you now that you've completed your project? Will you continue to build upon this, or will you pivot?
So currently I'm still making the audio signal processing tool. I finished making the model, but I still have to make the actual website so that other people can actually use the tool. And then after that, one of the limitations in my project was the accent. So I got my data set from a British hospital. So some of the patients, or most of the patients, had a British accent. So I'm wondering whether that accent could play a role in the model's accuracy. So I was thinking of maybe doing accent classification so that the model could better detect the disease.
Oh, very intriguing. Thanks for sharing that, Pavithra. So I am going to now welcome Shuhul Mujoo to the podium. Shuhul, when you're ready, start sharing your screen and I will make your video on Spotlight. Take it away.
Okay. My name is Shuhul Mujoo, and I'm presenting HGI-SLAM, loop closure with human and geometric importance features. The problem that my project solves is, how can a robot localize itself in a dynamic environment? Some applications include self-driving cars, rescue missions, warehouse robots, and delivery drones. All of these need to be able to navigate unknown or changing surroundings. SLAM, or simultaneous localization and mapping, is about using sensors to map the environment and updating the position of the robot in that environment. Sensor input is collected and then used to estimate the position of obstacles in the surrounding. This is then used to create an internal map, which helps the robot determine its position. In my robotics team, the only certainty is uncertainty. The same precise sensors that work perfectly during practice end up causing a robot to go astray in the actual competition, especially in the presence of other robots. It was this issue that led me to create a robot that could navigate dynamic surroundings while keeping track of its own position. SLAM grants robots the potential to accomplish this very task. The diagram to the left shows how SLAM can improve robot navigation. A key component of SLAM is loop closure, which is the process of correcting errors in the map once a loop has been created. Loop closure involves place recognition, or determining whether the robot has been to a location or not. In order to do this, important key points are selected from the input images, as shown here. These are then converted into descriptors which describe the image. Finally, images with similar descriptors, as determined by bag of words, are marked as loop closures, which is then used to update the map. This is how SLAM is used in robots to track their surroundings. Our method improves on the loop closure of path methods. The state-of-the-art SLAM system is OrbSLAM, which does everything from map generation to loop closure. OrbSLAM uses stereo vision, or a two-camera setup, or LiDAR. In order to detect features, OrbSLAM uses ORB, which is a fast feature detection algorithm that focuses on contours and contrast. The state-of-the-art loop closure detection system is Symbo LCD. It uses machine learning, a CNN algorithm, to create descriptors and identify similar images. This means that it only works well in indoor environments where it has enough trained labels, and it's slower than bag of words, which is what our method uses. The idea to combine geometric and salient features is what inspired HGI-SLAM. Our system is fully monocular, which means that it does not need expensive sensors. The combination of feature types leads to more accurate loop closures, even with large viewpoint changes. Part of the method involves a novel description generation method that can be used elsewhere in SLAM systems. Keyframe storage is also optimized for faster runtimes than OrbSLAM and less translational error. In terms of loop closure detections, our method has both better precision and recall, which means that it misses less loop closures and has to try fewer times than previous methods. The two pictures on the right show the different feature types and what they target, with salient targeting the salient heat map targeting objects and geometric targeting key points. Figure 1 demonstrates how our entire HGI-SLAM system works. A summary of our method is that it processes frames through two systems, merges them together, and then uses similarity to select a candidate frame, as shown in the picture. Figure 4 shows some sample loop closures and their corresponding frames. Figure 5 shows similarity between two types of features. They're mostly dissimilar, but in some specific situations they align. For example, when there are a couple of objects on a featureless background. In the end, I created a novel loop closure and descriptor generation method and implemented my own end-to-end SLAM algorithm into my robot. Some future improvements could be making detection more immersion blur resistant. On our first iteration, we submitted the paper to IROS, which is a highly regarded journal on robotic systems. I then incorporated their thoughtful feedback into my paper, submitting to the ICAR journal and then archive. The image at the bottom is from the archive page. I also want to sincerely thank Dr. Vadala for endorsing me. The entire research process was really fun for me, and I've never felt this accomplished. Thank you for listening to my presentation.
Awesome. Thank you, Shuhul. I'm a digital product designer myself, so it was really fascinating to learn more about loop closure, see heat map and green dots, and also learn more about how robots can localize itself in a very dynamic environment. So one question from the panel was, what was the hardest challenge you faced during your research process?
For me, I think the hardest challenge in my research process was definitely starting the paper, because I was going into a completely new field. I really had no idea what any of the terms meant, feature detection, anything like that. I didn't really know what it was. So in the start, I felt kind of lost, but eventually I gained my footing and then I was able to create something.
Awesome. So now we have one more presenter left. Let's invite Aayush Asthana. Aayush, if you're ready, start sharing your screen, unmute yourself, and I will spotlight your video so everyone can see.
Hi, I'm Aayush. and my project is analyzing the impact of network latency on graphic jitters and fairness in multiplayer online games. $30 million. That was the prize pool at the Fortnite World Cup in 2019. There were millions of participants, and each and every interaction mattered, with 100 players playing in each game. Let's put some context to the problem. Player 1 joining the Fortnite lobby may not have the same network bandwidth or processing equipment as player 2. This results in two problems. One problem, obviously, is unfairness between the players. A player with better network connection and a better PC might have an unfair advantage over other players. Additionally, when there are different network latencies playing in the same lobby, then there are many graphical stutters. Now I need to elaborate on the goal of this project. So my problem statement is to study the effect of network latencies on real-time multiplayer online games in the form of inconsistencies in the end user's view of the virtual world. Some of these terms need a double click. The effect of network latencies refers to varying network latencies and throughput and lossy networks with packet drops. The real-time multiplayer games chosen for the study are first-person games that have a heavy reliance on reaction time. Inconsistencies are measured through graphics jitters and unfairness, and the virtual world is where entities are sharing locations and timestamps. So let's get a better understanding of this problem. As you can see here, there are 3 players in a virtual world connecting to the same server, each with varying network latencies and throughput. This creates inconsistencies in the views of the 3 players. For example, player 1, which is the blue player, sees that the orange player or the yellow player is pointing downwards, where in reality on the yellow player's screen, he's pointing directly to the right. Additionally, you can see that there are some inconsistencies in the positions of the players. Multiple clients will connect to the same server. So let's define this. A client renders a virtual world to each player, and each virtual world will have a local snake representing the client. Each virtual world will also have virtual snakes representing the enemy clients. The server maintains a logical instance of the game, which means it doesn't have to render the game. It also supports clients joining or leaving the virtual world. It sends updates to each snake Now, if we want to run multiple scenarios, we need a snake that behaves like a human player, because humans are not capable of running hundreds of scenarios. To do this, we have an electric field-based heuristic client. This client assigns charges to each object in the game to determine the movement of the client. Positive charges are wall blocks, the client itself, and enemy snakes. The negative charges are fruits, so they will attract. The force vectors are determined using Coulomb's law. The F represents the resultant force magnitude. Q1 and Q2 are the 2 objects' charges, and D is distance. Fruits are assigned a charge of -20, and the client has a charge of +1. Wall blocks have a charge of +1, and enemy snakes have a charge of +28. These charges for the electric field were designed for the client to play optimally. At a given time, a snake may be attracted to the fruits, resulting in vectors as shown. and it will be repelled from walls and the enemy snake blocks. And when these vectors are added, you get the snake's next movement. And this is done repeatedly to move the snakes. Now let's look at our data. So we ran 10 scenarios where the first client had 0 network latency and the second client had increasing network latency as shown on the x-axis. So we saw that the max variance from either client having a 0 latency was so when both clients had 0 latency, the delayed client or client 2 won 7 out of 10 scenarios. When the maximum variance from this was only 5, was the delayed client only winning 5 scenarios, as shown on the delay of 200 milliseconds. This shows that network latency may not actually create a major impact on game fairness. The other thing we looked at was graphical stutter. Here, as you can see, the average pixel displacement, which is a measure of the graphic stutter, had a direct correlation with the network latency. As the network latency went up, the graphic stutter also had also went up. This shows that network latency causes a significant increase in jitters and reduces the overall gaming experience of both clients. Future works with this project include increased variety of data to see the effects of things like varying the charges in the electric field, or having more scenarios to get a better picture of how much network latency impacts fairness. The other thing, another future work is that we could make a neural network based on we can make a neural network to predict the position of the snake to hide lag. Thank you.
Wonderful. Thank you, Aayush, for the well thought out presentation on the network latencies on real-time multiplayer online games. I think the visuals that you used in your presentation was very helpful to follow. So one question that was sent to you was, what was the most unexpected thing you learned during your research process?
So the most unexpected thing was definitely here, where we noticed that when the network latency went up for one client, that there wasn't that much of an impact on game fairness. Perhaps if we increased the number of scenarios, then we could see a greater variance. But here we saw that there wasn't much of an impact on game fairness from increased network latencies.
Okay, got it. Great job, all presenters, on your research delivery and being on time. Now is the time for Q&A. And one of the earlier questions that I got that is for all of you is, what advice would you give to another student who's just starting research on your very topic? So we're going to go in the order of presentation. So why don't we start with Tony?
Some advice I would give is that don't get discouraged. Like I know sometimes like during the when I was studying, I was kind of discouraged. It seemed hard to do research, but as I went on, it became easier, and I ended up learning a lot and learning a lot of interesting things. So yeah.
Great. Pavithra?
I think one thing is that whenever you start a research project, since research takes a really long time to actually complete the whole process, you should always choose something that you're very interested in, because if it's not something that you're interested in and you do research on it, you may lose interest in the middle, which is not good for the research process. And also, like Tony said, don't be discouraged because research takes a long time and there are many people in the field. So there are people to help you out as well.
Great. That's a great advice. Shuhul?
I would say that to read the other papers in the topic that you're doing, and read them carefully, and then start the implementation as quickly as you can, because that's going to take a lot of time. And yeah, just be careful about what you do.
Got it. Nice caveat. Last but not least, Aayush?
I'll say that you can plan for things to not go as you predicted, because a lot of the time you might hypothesize that your data will have a certain result, but once you actually run it, you'll have a different outcome. But that's okay, because you can show that that outcome was the result of your study.
Got it. I have one more question. I think actually it'd be a lot more engaging if you guys can turn on your video. And this was a question that I asked Pavithra, but I realized that this was a question posed for everyone. So starting with Tony and then Pavithra, I have a different question for you at the end. So what initially drew you to your very topic of research? What motivated you to start researching on this topic? So Tony?
Oh, okay. So about a month or so before research, I attended this, I think it was an online seminar, and they talked about natural language processing, and it just really interested me, the topic. And so I decided to go into it. So, yeah.
Got it. Yeah, that's a good example of how like attending different sessions and talks like this can really initiate a new research prompt. Shuhul?
Yeah, so I'm the captain of my robotics team, and for the robotics team, our robot was having trouble with mapping, like the sensors we were using weren't accurate and everything. So that's why it was kind of a need to develop like a SLAM system to map everything. So that's why I started.
Got it. Cool. How big is your team?
At the time we had 10 members.
Oh wow. That's in your high school?
No, we're in a community team.
Oh, got it. Okay, cool. Aayush?
Sorry. Sorry, what was the question again?
Oh yeah, the question was what initially motivated you to pick this topic and start researching?
Oh, yeah. So I played a lot of video games before I started researching, and I noticed like in the video games that like lag caused a lot of problems in the player experience. So I thought it would be fun to go deeper with it and research the effects of it.
Got it. And to you, Pavithra, of now that you completed this chapter of research, do you have any next research question in mind that you would propose to the field of audio tools and Parkinson's disease?
Yeah, I'm kind of like curious on how the different fields that audio signal processing could actually be used in, because the purpose of me doing this project was to like come up with a real-time like detection tool kind of thing.
Mm-hmm.
And so I was kind of wondering how like audio signal processing could be used for other fields, let alone the medical field. So yeah.
Great. So one last question that came in a couple minutes ago. This is more of a generic question, but other than the research findings you shared, what was the most unexpected but interesting thing you discovered during your research process? So Tony?
Honestly, the most unexpected thing was I learned was how fast that natural language processing has like gone over like the past few years. Like when I was born in 2005, like natural language processing, like I don't even think backwards was like it was like new. So a lot of it was a lot of AI was in its infancy, and it just amazed me how far it's gone over these past 15 or so years to be able to compete with human translators.
Great. Shuhul?
For me, I think it was just the potential that I had to do things. Like I didn't know that I could be able to work on these kind of research projects. It looked pretty distant at first, but the fact that I could actually understand the current research that's going on, that just kind of made me surprised.
Got it. Aayush?
For me, it was how quickly the scope of your project can change. After you do some work on it, you see that, oh, there's more to this problem I'm trying to solve, and you can try to expand the scope of the research.
And did you kind of really talk that through with your mentor as you kind of readjust your project scope?
Yeah, I think my mentor was really helpful in that he guided me. He gave me like guiding questions to think about where I can take this project next.
Got it. Pavithra?
For me, like this project was one of my starting points for data science.
Oh.
And so at first, like I attended like a boot camp for data science, but like I didn't really do a whole project or anything on it. And so this one allowed me to like delve deeper and actually use like the different machine learning algorithms. And so it was just surprising how much I could do in just a few months with like the knowledge I had. And like it was interesting that I could pick it up like within that few months. Like whenever I had like a question or something, there were a lot of like helpful resources for me to use.
Mm-hmm.
So I guess like that was the most like surprising thing to me, because usually whenever I hear of research, it's usually like you have to do like a lot of background stuff, like other than just reading like the research papers and stuff like that. For like computer science related projects, like you have to know a lot of like the coding aspect and stuff like that.
Mm-hmm.
But like it was just interesting to see how much I've come in like those few months.
Awesome. So let's make sure that I'm not missing any questions that was sent to me through private chat. I think those were all the questions. So congratulations to all of you, to all the presenters on reaching this milestone in your research journey. Please do check out other sessions and presentations. And thank you so much for your presence today.